thank you everyone for coming for this presentation, right? I'm Pablo Santos, I'm the founder of Codit Software. We developed two products. You have the logos here, SemanticMerge, which is going to be the topic of this presentation, of this talk. And we also develop a version control system.
I can't hear you.
You can't hear me? Okay. Okay, I can speak louder, probably. No? That's not working? This thing should work, right?
Move it a little bit higher.
Higher. Not sure. Like this is okay? Is it better now?
No.
No?
No.
No? No, not at all?
You can just remove these speakers. Yes.
Not sure what, I mean, do you hear it on the speaker? Yeah, so maybe it's that song only, could be, because I think I'm hearing, I mean, I hear my own voice coming from the speaker somehow, so I think it's, can be me, right? Can you check if? Okay, let's do a quick test and then. Yeah, like this? Is it better now? Or you can still hear me?
Hear you fine.
You hear me fine?
Okay.
Okay? Okay, thank you. Okay, so I'm Pablo Santos. I'm the founder of Codit Software. We are a Spanish startup. We develop two products, Plastic SCN, which is a version control, so we are always involved in these things about merging and so on, and then SemanticMerge, which is what I'll be talking about today, right? Well, the topics I basically going to cover are the ones that you have now on the screen. First, well, how to handle refactor code with Semantic, which I think is the main topic for the presentation. Then, also I'll tell you a little bit about well, what's under the hood, what happens in the tool in order to handle all these types of conflicts, which I think it can be very interesting. And then I'll tell you a little bit about well, the next steps we have in mind to mix together the two technologies, right? But in order to start, I'll give a little bit of a description. During the last years, especially since the half of the last decade, we've been in a real revolution in version control. It seems before that, everyone was saying, okay, version control is just a commodity, so it doesn't really matter which one you use. It's just, all of them are the same, right? But then Git came here, also Mercurial. We also started developing Plastic SCN back in 2005. And then all these new distributed version control system went mainstream. So operations that not everyone was so used to do a few years ago, I wouldn't say everyone because there were other products able to do part of the things these new ones do, right? But some of the products were not able to do very good merging or very good branching, stuff like that. But now almost everyone is used to that, or at least I've heard about that, thanks to this, revolution of the distributed version control systems. But when it comes down to merging, and since we are still using in diff code, the same old tool we used 20 years ago, and maybe some of you were not even born there, right? So, with distributed version control, you can do amazing things because, well, this is a look of our own visualization in the version control product we have, but I think it will be the same with any of them, right? You have a lot of branches, and you have to go and merge from this to there, and then the system is going to be able to calculate which is the nearest check-in, the nearest commit you need in order to perform a correct merge. And that happens because of the internals of the system, right? And all the new systems like Mercurial and Git and Plastic and so on can do it, which is very, very powerful. But after that, what the system does is calculate three elements, three files, right? Your file, how the file was, and then the ancestor, which is what you basically need in order to merge. And there is where the problem starts. As I said, what you see here on the screen is basically all the merge tracking any modern version control tool is able to perform, right? But at the end of the day, you need to go and merge the files. And when you go and merge the files, we are still in the 80s, right? Because you need to invoke an external tool. Different systems come with their own tools, but they all have the type of problems that I'm going to show you now. Suppose you have a class like this one. This actually, well, it could be C# code, but actually everything will be the same because I'm just thinking about the structure, right? So you have a method here, and that's your file. And then two developers start working at the same time. Of course, I'm going to show a little bit contrived example for the sake of simplicity here, but it wouldn't probably happen like this in the real world, but it will happen probably during a week or a week and a half, not in 3 seconds, but anyway. So one of the developers now goes and moves this remove method and puts it there, right? Which is a very simple operation. Why the guy is doing that? Probably because he wants to improve the readability of the code. Maybe he just read, he just went through clean code or something like that and said, okay, now I'm going to write my methods and sort my methods in a different way. So that's one of the guys that's what one of the guys does. And at the other, on the other side, the developer decides to go and move the same method down. And they were also modified, right? What a regular text-based merge tool will do here? Well, what a regular text-based merge tool will do is, okay, let's combine this and this, these two. And then it will say, okay, no problem. You see what? This block of text has been added. This other block of text has been added too. So you will end up with two remove methods and an automatic conflict. It won't even ask you, right? The two methods will be there. That's not a huge problem, right? Because, okay, then you compile and then you find an issue and so on. But of course, it's not acting in a clever way because the regular text-based merge tools don't understand the code, right? Okay, so as I said, when you start comparing, yeah, that's basically what I wanted to show, right? You get the solution, and then you will get the two remove methods, even that at the very beginning there was only one, because the system, I mean, the regular merge tool don't know how to handle this. Okay, so what will SemanticMerge do, which is the tool I'll be talking a little bit about? Well, instead of just detecting two other methods, it'll show you an interface like this. Probably the ones that are far away won't see it very clearly, but what it's doing here is just saying, okay, you have a remove method that has been modified by the two contributors and also has been moved twice, right? Why is it able to do that? Well, because Semantic is a little bit different than other tools. What SemanticMerge is? Well, it's a three-way merge tool. Three-way, remember, I think it's clear for everyone here is that it uses not only the two versions of the file to be combined, but also looks for the parent, right? The version control system actually provides with that information. And then it's refactor aware and programming language aware. What I mean by that? Well, instead of handling the merges on a block, line by line basis, like any other version control will do, what it does is what all of you are expecting, right? It parses the code first, then it generates the code structures, then it merges based on that, right? And that's basically the main difference with other tools. This is actually something that we've been trying to develop for a while because, well, we have also developed our own text-based merge tool for the version control system we developed, and of course that's a general purpose test merge tool. It's not dependent on the language. But once we had that, we decided to move forward and try to come up with something different, something that is tied to the specific language you use. So it's not general purpose. We have to develop one language by language support. So far we have C# and Java. We are working on C and C++. Then we get a lot of requests from JavaScript and then Objective-C and then almost anything on earth, right? And of course, it will take some time to develop all that. But basically, what we try to come up with is with a tool that is able to help. I mean, what's the theoretical thought? Let's say the initial thought we have when we try to come up with this. Okay, if you want to keep your code clean, if you want to keep your code base somehow maintainable, right, and easier to make modifications, and you try to avoid the classical cost of change curve that you all have seen, that the cost of change higher and higher depending on the phase of development you perform a change. If you want to avoid that, you will need to do refactor. If you want to do refactor, you need to change code to a different location, split methods, all that. And sometimes you won't do that because some other developers are fixing bugs or doing changes or something like that, right? So you have to stop, refactor, then someone else does something different. What we try to achieve with this tool is to give developers another tool, of course, not a magic bullet or something like that, right? It's just another tool that you can use in order to, you know, boost or at least increase the number of refactors you will do on your code base. Okay, some of the data we found, because in order to test the entire thing, we did two things. First, we replied a lot of merges from repositories downloaded from the internet, like 50,000 GitHub repositories, something like that, right? And then what we found out is two interesting numbers. First, that right now, even that people try to avoid, you know, moving methods around and stuff like that, 23% of the conflicts are what we consider semantic, which means they are easier to solve if you just consider that a method is a method independently of the position where it is, right? And the second thing is that normally you have to review less code because, you know, since it's actually able to locate the exact piece that is in conflict, you reduce the chance of having to look into a big chunk of code. Okay, let me now go to a real scenario, right? So I'll show you a scenario live. I'll first describe it, and then I'll jump to the tool and show you how it works, right? Well, let's look at this graphic. What you have in the middle of the screen is a socket class with a few methods, right? Just forget about the other two, which are just the two modifications made by the two developers. How we normally represent this is that we put in the middle how the file was, then on one side what one of the developer does, on the other side what the other developer does, right? So suppose you start by this, and then now you decide to refactor a little bit your class. So you create a new subclass called server socket, and you move two methods there. Quite simple, right? On the other hand, other developer goes and create a client socket class and move two methods there, right? Okay, so this is the scenario. Now I'm going to try to solve it with a regular text-based merge tool, okay? As a human, you see that and say, okay, there's no conflict. You just moved two methods to a subclass, another two methods to a different subclass, so it's obvious, right? Let's see what a regular merge tool does. So this is socket example. I'll run it. And this is a three-way merge tool handling the conflict. The first thing you find is that it's saying you have three non-automatic conflicts. So it's finding three things that it cannot solve, right? Well, this is our own merge tool, text-based merge tool, but I could be using here Araxis, or I could be using Beyond Compare, or Perforce Merge, whatever, right? And basically, the problem will be the same. What is the issue? If you look here, you'll see that it's trying to match the lines change on get host by name with the ones here in get host by name, which is okay, but then it's trying to match it with recv, which is not okay, right? And the thing is that, look, this is how I change the class, right? So I moved method up and so on. I moved some methods up, some other down, and so on, right? So basically, it's a nightmare for the system. This is a very simple example. The methods are just, you know, they just have comment as body to make it shorter. But in real life, you will probably say, okay, I cannot solve this with the merge tool. Let's close it. Let's open up the files with my editor, and let's go line by line trying to solve this thing. So next time someone tells you, let's refactor the socket class, you will say, no way. Okay, so let's now try to solve it with Semantic. So what Semantic is going to do, here we go. What Semantic does is, okay, there are no conflicts to check. Why there are no conflicts to check? Because it tells you, I was able to solve the merge automatically. If you look to the result file here, you see that I have my server socket class with the listen method, I have my client socket class with the send and connect to, and I have my DNS class, which is a renamed one with the result. So it was able to deal with the same conflict that a regular merge tool was not able to solve and do it automatically. In fact, the nice, well, I hope you like it, the graphic that I had on the screen is something that the tool is able to show, right? This is my favorite part because basically, in fact, one of the ideas we have now in the team is try to make this the primary interface, right? So you end up solving the conflicts in this interface instead of the other. Right now, we just use it as a visualization that helps you understanding what is going on. You have your base, your changes, their changes, and then you see what happened, right? And what you can see here is, okay, the socket class was renamed to DNS. The R means rename. You also see that the get host by name went to the, was changed. Okay, and also two methods were moved to client socket, and as you see, to make it a little bit more complicated, what I did here was to actually swap the method location. You see that? So send went first, then connect to went second. Actually, what SemanticMerge is doing here is that it doesn't, I can put the methods in whatever order that I want because the tool won't get confused by that, right? It's simply not merging on a position per position way. So this conflict was able to be solved automatically by the tool. Of course, some of you will be thinking, okay, but I don't have these kind of conflicts on a real basis, and that's right? You normally don't do this every day. But if you're working on a branch and have to do some fix on an old version, for instance, and then you have to merge back this fix that you find in version 1.0 of your product into 2.0, then chances are this kind of stuff starts happening, right? So let me now move to a little bit more complicated example. Well, I won't save the result now. Well, it works exactly as a regular merge tool. When you want to plug your merge tool in Git or Mercurial or Subversion or whatever you use, you have to, specify a set of arguments on the command line that you pass to the tool. This tool works exactly the same, right? So this is what it will do. In fact, you have arguments. So for instance, in the case I just ran, that it was automatic, you can avoid the merge tool to show up. If it's able to be solved automatic, it won't even ask you, right? Okay, let's go to a different case. I don't know if you can see it correctly, but this is like the second part of the first test scenario, right? So it's like a sequel or something like that. So we start with the previous test scenario. We have a class with 3 subclasses: server socket, client socket, and DNS. And then what we do is that the listen method is going to be moved to 2 different locations, right? By 2 contributors, by 2 developers. So the listen method go to the DNS class, and the other guy decides to move it to client socket. So it's going to be on a different location, modified by the 2 developers. And okay, again, this will be a little bit of a nightmare for a regular merge tool. I will show how it looks. So I'll try to run it with a regular merge tool, and it says only 1 conflict. Say, oh, wow, cool. But if you look what's happening, it's trying to merge the listen method with the connect to method, which doesn't make any sense, right? So again, you'll have to close it, try to figure out what's going on here. Well, not nice. So let's now go to Semantic and check what happens. Now you see that it's not saying it's automatic like the first time, which is not so good, but it's still able to focus on the real conflict. So what it's saying? What it's saying is, look, you have 1 conflict on the listen method, just that. In fact, one of the things that people tend to ask us is, why did you guys come up with this interface instead of just putting side by side like any other tool will do? Because the side by side is very good when the methods are not swapped. But as soon as you start swapping methods or something like that, it's a nightmare to follow. That's why we try to come up with a very simplified way of looking into the conflicts. So it could be a very simplified, or it could be really bad, depending on what you like and whether you like it or not, right? What we try to come up with is, okay, let's just focus on the conflict. So there are many methods on the file, as you saw. They were moved around and so on, but there's only one that you really care here, and it's the listen method. And saying, okay, it was changed on source and changed on destination. You can go and merge it, and I will do it now. And then it was also moved into contributors. So what do you want to do? You can solve first that, and then the real destination of the method. So what I'm going to do is, okay, where do I want to keep it? on client socket or on DNS, because it shouldn't be on the two sides, on the two places at the same time, right? Because I had, well, what I did, I'll show you again the graphic, it's actually a divergent move, right? So it's going there or it's going there. So you have to choose which one you want. So what I'm going to do is, okay, I'll keep the destination, very simple. So I keep it on the DNS class. And then I will merge the method. One of the beautiful things here, in my humble opinion, but of course I'm a little bit biased, right? So one of the good things here is that you focus on the merge of the method. Only the listen method is here. If there are any other conflicts on the file, you will be handling them one by one. In this case, the conflict is automatic. So, you know, it was modified on source, modified on destination, it's automatic. I will save and exit, and it will get the result on the right location, which is the one I selected before. One beautiful thing here, I was about to tell that later, but I think it's interesting. One of the things that we can detect with Semantic is the following scenario. Suppose you want to make all conflicts and methods manual. You can't do that with a regular test-based merge tool. Okay, so suppose you have this type of conflict. Actually, it was modified on the first line and also on the last line of the method. A regular merge tool will make it automatic because the two lines are not colliding. But you can say something like, okay, but if there's a conflict inside the body of a method, make it always manual because probably it's worth taking a look into the code, right? So you can do that because it actually knows it's inside the same method, right? So actually, this was not a goal when we started. It's just, you know, something we found out and it looks good, and it's just for free once you have the rest of the implementation. So once it's solved, I will just save and exit, and then if I go and view the result, you see that inside the DNS class, you see the listen method with the modified on source, modified on destination on the right location, right? So this is part of the beauty. Well, I didn't show in my original, in the slideshow, but I also had modified another method, which is connect to, right? And what happened to this connect to method? Let me show you. This connect to method was modified in one of the contributors, but it was deleted on the other. So you can again choose. What do you want? Keep the deletion or keep the change? And depending on what you choose, the conflict will be solved in one way or another. Well, actually, what we are applying here is exactly the same algorithms we use in Plastic SCM for merging files and directories, right? That's what we now apply inside the file with Semantic. So part of the development for us was, okay, figuring out how to apply the same mechanisms that we already do for files inside the single file. It's not the same code, but it's mostly the same algorithms we use for the version control. So in Plastic SCM, you can detect things like divergent move of files. You rename one file, your colleague renames and puts the file on a different package. So when you merge, the system tells you, okay, what do you want to choose? One or the other. It's exactly the same thing as I show you here, right? Okay, so this is one of the hopefully beautiful things we can do with Semantic, right? Okay. So, yeah, well, and this is what I was telling before, right? It can detect conflict that regular tools can, like if the same method is modified concurrently on different lines, or also, yeah, we can force manual detection there, and also we can do interesting things. For instance, that's not very dangerous, but it's useful. What if you add a using or an import, or even an include once we finish the C support, on line 1, and I exactly add the same thing on line 7. SemanticMerge will detect is the same thing. It's going to be more difficult with C because there the position is not, I mean, you cannot play with the positions in C and so on, but if you do it in Java or C#, it can detect that it's the same using, so it will only import it once, right? It's something that you can add. Also, some of the other conflicts, I think I have another 2 conflicts to explain a little bit later. So, well, under the hood, what's going on here? At the end of the day, well, there were approaches to try to come up with semantic. In fact, whenever I go and do a demo of for a version control system, and I wouldn't say all the time, but very often, right? I go and do a demo, and then when I enter the merge part, a lot of developers, especially when they are young and they are not very familiar with merging, they ask, but this thing should understand the code, right? And before I ever developed SemanticMerge, right? And then said, no, but you know, the state-of-the-art tools don't do that so far. And said, okay, yeah, but the natural thing will be to understand, right? So previous approaches, because some other people tried to do that before, try to parse everything. What we do is, okay, we parse the file, but we merge based on that structure. As you can see, it's just, you know, where the methods are, where the classes are, where the namespaces are, where the imports are, but we don't enter inside the body of the methods. The body of the methods, we merge them as if they were text, right? Why we do that? Because otherwise we explode the complexity. I mean, we won't enter into semantic merging an if and an else, or whether you change the if condition or something like that, because maybe we do it someday, but we decide, okay, let's stop at the body level, right? So what the system does is, okay, you have a file like this with 3 methods, so it will generate that, is like an AST, right? It will generate the structure of the class. And then it will merge based on that. So this is basically the procedure of what's going on. So it takes the 3 files, it parses the 3. Question 1 now, what happens if you cannot parse a file? It will say, I cannot parse the file. So go back to your old merge tool because I cannot handle that. Fortunately, it doesn't happen so often, but if it happens, we directly go and jump into the default text-based merge tool, because otherwise we could, you know, break the entire thing. So once the 3 files are parsed and we have this structure, we run what we call the differ, right? It will run a diff based on the trees. So what it will find is, okay, this method was added, or this method was deleted, or it was moved, and all that, right? So it starts working on a method per method basis. Here we use some of the previous technology we have in the text merge tool, which is able to find methods, blocks of text that are similar. So when comparing two methods, to know, suppose you rename a method, how do we know it's the same one just renamed? Because it's going to compare whether, you know, it's similar to another method that's not there anymore. It's very similar, it's pretty similar, okay, then we conclude it's the same, right? And then we generate 2 pairs of differences. Basically, we diff the source and the base, the destination and the base. And based on these 2 pairs of differences, then we run the merge. And from the merge, we get operations that can be applied directly, like in the first example, just move this method there or delete it or do whatever, right? There's no conflict. Or if there are conflicts, it will generate a list, which is what the GUI will render and will try to help you to go through, right? Okay, some interesting cases that we can detect. This is what we call the cyclic move. This is a little bit, well, I don't think this happens very often, but this is a very interesting one to go through. Suppose you have this structure, right? You have a namespace, then you have a class socket, then a subclass called utils, then another class DNS. Of course, this will be, this can happen in C# code. It's not so common in Java unless this will be another class, right? So suppose what we do in one of the contributors is that, okay, let's move the class socket into the class DNS. So this goes inside. And then on the other hand, what we're going to do is to put the class DNS inside the class utils. So somehow you try to merge this, you will get a cycle, because socket is inside DNS, but DNS is inside of socket, right? This is not very common, but it can happen, especially, you know, in big classes and so on. The system will detect this and will do exactly the same as I showed you in the previous example, which is, okay, which one do you want, one or the other? Let's go for a more real world scenario. What if you add 2 methods? Suppose we add a send method to the class socket, but instead of adding it exactly the same location, we add the same method, but on different locations inside the class. I add it at the bottom, and then you decide to add it at the very beginning. The system will detect that and will handle it automatically as soon as the methods are exactly the same. If they are not exactly the same, it will find an evil twin conflict. Okay, it's all very familiar, you know, twins, parents. And so what it will try to do is, okay, we have the same methods. If it's not automatic, it will try to do a two-way merge of the two bodies of the methods, and then it will place it on the location you want. Okay? So that's a little bit of some of the cases that the system can handle. Probably you are thinking about, well, before going through the next steps, I'm going to show you something else. Probably you are thinking, okay, but all this stuff you are telling us that just applies to a single file. So if I'm going to move a method, it's very likely that I would like to move it to, you know, a different file, right? Or split a file into two files or something like that, right? This is what we call multi-file semantic merge. This is part of the future steps. What I'm going to show you today is a proof of concept of it already working. It's not what you get on the commercial tool. If you go to our site today, we don't have the multi-file. And the main reason for that is that you need to make small modifications on the way the version control system invokes the tool. So we cannot stick to the regular interface because we need a little bit of more information. Basically, we need all the files involved, right? So we did it for Plastic SCN, which is our own version control system. But if we want to do it for Subversion or Git and so on, we'll need to make slight modifications on the way they run the code. It will be doable for the open source ones because I think we can create a small module. It will be a little bit more difficult for the commercial ones. But most importantly, the reason number one why we don't have it yet is because we still need to figure out a better way to handle the visualization of the conflict, right? What you have here on the screen is exactly the same socket example I had at the very beginning, but now multi-file. What happens if, which is much more natural, right? You have a class, you have a file, you have a socket class, and then you move two methods into a new file, and then you move two other methods, well, okay, on the same file, then you create a new server socket file with the server socket class inside. On the other hand, you do the same with the client socket and so on. So I'll show it up and running. For this scenario, it runs perfectly because basically it's very, very simple. But what happens if you get, instead of 3 files, 20 or something like that? We need to figure out how to group them because maybe some of the operations are not related to some others and so on. Let me just show how it looks like. In order to do that, I'll show you an example. So I'm going to merge this file. Forget about these two branches right now. So what I'm going to do is to merge this one into this one. Now I'll show you a little bit of what happened here. So I have the socket class, and then you can see the method connect to is not there anymore, and the method send is not there anymore, right? The reason is that they were added to a new class called client socket. Well, one of the things we already miss, as soon as we started using with Semantic ourselves in development, one of the things we miss is a way to show this in a semantical way. Because now you look at the diff, right? You have to check one file, check the other, and figure out that you're doing a refactor. If you have a multi-file semantic diff, you will figure out that it's just a refactor, right? As I will show later. So this is one of the things we have planned to continue working on. And then, on the other hand, this other guy here, what he did is, okay, from socket, he created instead of the client socket, he created the client socket, right? So what I'm going to do right now is to merge from this branch. I process all merges. Semantic will show up, okay, and says there are no conflicts. In fact, you see it's not exactly the same interface as I showed before because this is a proof of concept started from a previous version, not the one we already have commercially, right? And it's lower and so on. Okay, it's saying no conflicts. Okay, I will save it, and I will show how my workspace is right now. And you see that I have a client socket file, right? Also have a server socket class with the method modified and also the class and so on. And then the socket class has been renamed to DNS. I didn't do the rename of the file too during the merge, but anyway, it will work too. And then it only has one method, right? So this basically, we expect to be releasing it around Q1 or Q2 next year, depending on the major challenge we have right now is, okay, we always have to choose, right? So we have a lot of requests from customers already saying, okay, please go and implement support for C or C++, so we try to do that first than actually doing this. So, well, I'll tell you a little bit about the roadmap we have. Okay, the second scenario I'm going to show you. Let me just undo this merge. Okay, so the second scenario is going to be a little more difficult. What I'm going to do is divergent merge. I mean, exactly the same divergent thing I showed you before, but this time multifile, right? So again, if I diff this branch, what I get here is the socket and server socket and client socket, right? But this time the listen method is going to be moved to one file in one of the branches to a different file in the second branch, and then we'll have to merge it and decide the right location, right? Sounds cool. Well, it sounds cool to me because I'm always in version control. Maybe it just sounds okay for you. Okay, so let's go. Whoops. Let me just check 1 second. Okay, so let me now go and merge from the other branch. So if everything goes well now, which I hope it goes, we'll see the divergent. Okay, here we go. So I'll show you the visual diff. I zoom it out a little bit if I can. Okay, I can. Okay, so look. Now it's showing 3 files. You see there's a file, the gray thing here, another file, another file. So what it's doing is, okay, the listen method was moved there or moved there. So exactly the same thing, but now multi-file. What we're going to do is, okay, let's solve the merge first. My case is, okay, move from server socket to DNS, move to client socket, class, and modified. I'll keep the 2 changes. They are just comments, so not a big thing. And then I have to decide where I want to keep it. In my case, I'll keep the destination, then I'm going to, okay, I also have another change on get host by name. This is not a very interesting one. I will just save and exit. And if I go to my working area, I'll see that I have my client socket with the listen method and the 2 lines, right? And this is basically it. So this is part of the new things we are working on. If I tell you a little bit about the next steps, well, I started with the most exciting next step. Well, we have a user voice place where we get well, JavaScript is right now the top request after macOS support. Right now we support Windows, Linux, right? And we are working on the macOS. Actually, the Linux version, which is based on GTK, runs on Mac, but we never release it officially because it looks awful, right? And we know Mac users like nice interfaces, so we are a little bit scared releasing it, to be honest, right? Because we want to come up with something that, you know, makes sense for Mac developers, so it should be beautiful and well finished and look native and all that, right? I wouldn't say a Linux user wouldn't expect that, but it's a little bit different. And on Windows, we are very used to work on Windows, so we think we know what more or less user want. So let's see. So next thing is we're working on C and C++. They are much more difficult to work with from a parsing point of view than Java or C#. I mean, I think that's clear for everyone, but also a lot of people is asking about that, especially big teams and so on. So we gave some priority to this one. Then we get a lot of requests from people saying, well, Objective-C is going to be on the same package. It's not the same thing, but I think we can handle them together. We are working, as I say this, full-time on that, right? Trying to come up with this solution. Hopefully it's going to be out before the end of the year, but you know, we only want to make sure, I mean, it has to be really up and running and very precisely. One of the things we do is that we use like 2 million files on each language instead visualbasic.net because we didn't find 2 million files on the internet. But anyway, for all the others, 2 million files to play with, and then like 50,000 merges and so on. So we are still through the process. We got a lot of requests for Ruby and Scala, macOS, and I already said, and then we decided to plug what we call the external parser support. So you can plug your own parser for whatever language you want. The first guys who did that were the guys in the Delphi community. They created their own parser, and it's already up and running in Delphi. We have to improve some stuff there. For instance, like, well, that's doable already, adding the specific icons for each language. So you see the methods and the classes and so on. It's very easy because it's just a directory with the icons, right? So it's very easy, but we should automate it a little bit better. And these are some of the things we have in mind. And then after doing that, of course, the multifile is there. It's something we have in mind from the very beginning, right? And then there are three other things. One of them is pretty interesting, and we released that like 2 or 3 weeks ago with our product, with Plastic, but it could be doable with any other version control, which is what we call semantic method history. You are on your IDE, Visual Studio or Eclipse or whatever, right-click on a method or function and say, history of this. That's something that you can already check on our system. If you go to our blog, you can see that. And what's the motivation of that? Because in my view, 90% of the times you check the history of a file, you just want to see the history of a method, right? So that's basically what it does. It goes through the history, looking the method, and so on. The second thing is some sort of semantic blame annotate. When you blame a file, when you do an annotate, SVM annotate or SVM blame or git blame or whatever, as soon as you move some code around, the annotate is not going to be correct because it's going to say the creator of all these lines was the guy who actually moved it, which is not correct. We could improve that using this technology. That's just an application of the same different technology. And then some of the other things we have in mind are, well, some sort of what we call semantic repository statistics. We can already calculate, we're doing just that internally so far, but probably we can put the product together to calculate, for instance, okay, the current status of the system, who are the people who has more influence based on methods or something like that, or instead of calculating a statistics based on lines added, modified, deleted, based on methods or functions or classes, this kind of stuff, right? And then finally, one of the things that we try to come up with is the semantic code review. So whenever you are reviewing code, one of the things that inside the team, we always review every task, right? So before actually putting it into production or into the next version or whatever, we do peer review. One of the things that are normally, I would say, discouraging is when you find a task with 50 or, I don't know, 80 files being modified, right? When you have only 3 files to review, you will concentrate and do it very, precisely and so on. You have like 80 files, it's going to be like, oh my God, this is too big, right? Then it's very helpful if at the first, and then you start reviewing the files and you find that 3, 4, 5, 6 already, they are only changing and using, right? So it would be cool if you could group that at the very beginning and say, okay, these 50 files only have simple stuff being modified, and the real big changes are here, here, and there. There's not a huge technical impediment to do that. The thing is that it can help because basically it changes your mind when you see the review. Instead of saying, oh my God, I'll do it after lunch, then you say, okay, it's only 3 files, let's go for it, right? So it helps. So these are some of the things we have in mind. I have a few minutes left if you have, like 5 minutes, right? If you have any questions, well, feel free to ask. Yep.
So you said you only parse the name of the methods. So what happens if 2 methods change the name but the content is exactly the same?
That's a good question. We don't only parse the name, but also the params and so on, right? But anyway, for your question, it's the same thing. Okay, if the bodies are the same, so suppose you have 2 methods which bodies are exactly the same, one of them renames the name and the other not. It could happen that it gets wrong. So we have an option when you diff, when you see the, I'll show it. Well, whenever you show the, when you show the tool, you can also go and see the changes on source, the changes on destination, right? And it basically shows the differences, not visually, as you can do here too, because this is the other part, right? It's not only a merge tool, but also a diff tool, right? But you can, what we say when you have a move is that you can go and unmatch, right? As you can see here. So suppose you did it wrongly, then you can unmatch and match with the right one. It shouldn't happen very often, provided that methods should have more or less different bodies, but it could be a very short method that only has return 1, the other has, well, not 1, return whatever, and something different, it could get confused. You can solve it this way.
But you could have directives, for example, the connect to is changed to connect, and in the same file there could be other changes that change the connect to connect. right? I'm calling
Okay.
connect instead of connect to. So that's kind of directive or hint that this name is changed.
Mhm.
It's a value change. So instead of showing this conflict, you could say it's just purely a method name change. So that it could be maybe simpler.
Okay, yeah,
You don't
that's
need to do anything manual.
okay. If it was just, I mean, if you just rename one method, it will find a.
You repeat the question he did, so everybody can.
Yeah, well, you were saying that it could be just a very simple method where you just rename a method, right?
Yes.
Is that okay? It could be detected. I mean, it will be detected this way. The only way where it will have an issue is if two methods that are very similar change at the same time. But one of very useful operations that you just rename it. It will just find it as renamed. It won't be a conflict, no manual intervention, anything. Okay. Okay.
And do you have any performance evaluation about this parsing thing?
How fast it goes?
How fast it goes
Okay.
compared to conventional?
It's a little bit slower. We don't have, I don't have the exact number here. In fact, one of the things that we improve a lot from the previous version to the real one, and you have seen it, right, is that it now goes much faster. In fact, normally parsing it is not slow. It's normally parsing the 3 files is normally less than 200 milliseconds on this laptop. I mean, it's not the one we use for testing, of course, but normally it's not big, right? So the only challenge there, as you probably have in mind, is what happens when you have to merge 150 files. They all go through the mechanism and so on. The GUI doesn't even start when that happens if the merge is automatic, so it goes much faster. Normally, the merge will take about 200 milliseconds. Regular merge could take about 50 to 80 or something like that, but it depends on the tool and the type of conflict, right? On the machine, of course. Okay.
If your tool merges automatically, does it give complete feedback about what it has done? Because I think that's the biggest problem I always have with merge tools. If they merge automatically, it's very hard to review what actually happened, and then maybe something went wrong and you don't notice.
That's a very good point. Well, the first thing is that you can customize whether you want the tool to show up or not. By default, it will always show up. The reason why we did that, especially during the beta phase, well, we released this commercially 15 days ago, right? It's been for like 6 months in beta phase. During all the beta phase, we didn't even publish the -a argument that makes it automatic in order for everyone who was using it to make sure everything was okay, right? So what happens once you finish this? Once you finish it and you check it in, then it's part of the version control system to really understand what happened. You can still configure it as diff tool, and then if you do a diff on your Git or Subversion or whatever, you'll still see the semantic diff, and then it will be easier to understand. No, I'm not sure if I answered your question.
You did.
Okay, thank you. Okay. More questions? Okay.
When do you think Mac support will be up?
Okay, that's a very good point. Well, in fact, we already started. We have I received some screenshots today from the team checking how it looks like. My goal will be to have it up and running before the end of the year. But, you know, the concern we have is that, as I said before, we really want to come up with something that makes sense on the Mac. So we are not 100% sure. I mean, it probably will be merging like next week already because it's already there and everything is working. And you will see an interface similar to this one in structure, but of course native Mac look and feel. But I won't say before the end of the year. I mean, probably end of December or early January or something like that. Okay?
For those that are living, we have an event on Runaway Building in Market Street on Thursday evening at 6 p.m. So if you want, we have invitations here in the exhibition area. We have them too. So if you want to invite colleagues, for those that are local, to come, we will do basically the same demonstration, but also share cocktails and food with the people from 6 to 8 p.m. at Market Street.
Okay. Well, really thank you for attending. Hope it was interesting for you, and of course I'll be around in the booth and so on if you have any questions or suggestions or anything. Really thank you for coming. Thank you.